Hello everyone. Welcome to the next simulation video on power electronics. In the today's video, we are going to construct the single phase half controlled converter, which is connected across 230 volt 50 hertz single phase AC supply. And we have to simulate this circuit with the resistive load of 10 ohm with firing angle of 30 degree and 60 degree. And case 2, resistive load of 10 ohm and inductance of 0.5 Henry with 30 degree and 60 degree firing angle. So see here in the problem statement, it is given as a half controlled converter. Half controlled converter means it is a bridge converter only, but there are two SCR and two diodes are used because it is having the control over the half circuit, so that it is known as a half control converter. It is also known as a semi converter because all four SCRs are not controllable. So let us simulate this. So first we'll take a thyristor. Okay, so you can double click on the screen in new MATLAB. You can directly search for a thyristor. Okay, so from the specialized atom you take the thyristor. Okay, the thyristor will appear on the screen. Okay, so this thyristor is appeared here. So let us rotate such that cathode terminal is on upward side and anode terminal is on downward side. Double click to this. Okay, double click to this, and we don't want any measurement. So deselect. Don't select this measurement. Okay, so measurement port is not visible now. So let us give this thyristor name as the T1 thyristor. Okay, this is the T1 thyristor. Now we need another one thyristor, that is the T2 thyristor. Now we need a diode. So go in the diode from the specialized power system block, choose the diode. Okay, the diode is appeared here. Again, you rotate this block. Here only I want the cathode and anode. I don't want the measurement block. So apply. Okay, so this diode name is, I'm giving this diode name as diode D2. So let us change this name as D2. Change this thyristor name as T3 thyristor because upper side are odd name and lower side are with the odd name, even name, sorry. So this is D2 and D4. So you look here, T1, D2, T3, D4. The nomenclature should be like this. Now we have to connect the AC supply across this. Before that, we will connect the bridge circuit. Okay, so let us connect the bridge circuit. It should be connected like the H bridge. Okay, so H bridge is to be constructed here. Now this is connected to anode. So let us shift somewhat here. Connect the cathode of diode to the anode of SCR. Now here we want to give the gate pulse. We'll think about the gate pulse later. First we will see the source. Now I need a AC voltage source. Okay, this AC voltage source is here. See, what are the specifications of the AC voltage source given in the problem? It is 230 volt 50 hertz supply. So let us rotate this source. I want to connect this source here. Just a minute. Okay, so I will connect this source here. I want to connect this source here, but before that I want to add the measurement. But let us set first the source voltages. Here in this block it is a peak amplitude, but we have given the RMS value. So RMS to peak conversion is 230 into SQR of 2. Then frequency we have to set it to 50 hertz. Okay, so now we have constructed the AC voltage source. Now I want the current measurement block to measure the input current. So I will take the current measurement block. Okay, let us rotate this current measurement block. I will connect this plus terminal here and minus terminal across this. I want to measure the source voltage also. So how to measure the source voltage? take the voltage measurement block. Okay, so voltage measurement block and connect across the source such that positive is connected to the dot terminal. Okay, so positive is connected to positive terminal, negative is connected to negative terminal. So by using the control R command, you can rotate the figure. Now rotate any block. So now I want a go to block. Okay, so I will take a go to block, rotate this go to block. I will connect the first go to block to the current. Okay, I will change this name of this go to block as this is the source current is, and I will make this variable as a global. Now take another go to block, connect here and rename it with the Vs. Vs is source voltage. Okay, so source voltage is connected here. Now, similarly, I need to give the gate pulse to this. So to giving the gate pulse, I will again use the block of from. Okay, so for a thyristor one, I have to give the pulse G1. Make it okay. So G1, and for thyristor 2, I need another gate pulse G2. Same gate pulse is copied and connected here, but this name should be changed to G2. Okay, if you want, you can rotate this block also. Okay, and give the connection here. Okay, so G2 gate pulse. Here, this block also you can rotate. And so if you construct the circuit in the good visualization, then it is very easy to track the circuit also. Now we have to connect the resistive load. According to this, resistive load is of 10 ohm. So take a resistance series RLC branch. In this series RLC branch, rotate it and take only R load. I want to set this resistance as a 10 ohm. Okay. I have set this resistance as a 10 ohm. Now I have to connect this with the resistance of 10 ohm. But I need a current measurement again. I want to measure the output current. So take a block of current measurement. Connect the positive terminal with this upper side of the H bridge. And negative terminal you connect with the connect across the load. Okay, so let us transfer this diagram on somewhat on downside. Select all and place the block of down arrow. Place the key of down arrow. Okay, now again take the block of go to. Okay, as this is my output current, so you can connect this, and I will give this name current as IO, output current. Connect this terminal of the resistance on bottom side. This resistance we have set it to 10 ohm. Now I want the voltage measurement block also. So take a voltage measurement block, connect the voltage measurement block across the load. This is nothing but the output voltage. Okay, here you will get the output voltage. So let us arrange in good manner. Okay, so here again take the block of go to. Sorry, in this go to block, I have not set this variable as a global, so make it global. So this variable is available globally in my this window where I want I can use. So change this name as a V0. Okay, everything is connected now. Now what we have to do, this is for a resistive load. So let us transfer this load nearby. So circuit will become a compact. Okay, so you can transfer this current measurement here. Okay, so you take this here. You can again bring this near to the circuit. Okay, then voltage measurement block. Hmm, okay, then this is V0. Now my main circuit is constructed. What is remaining? See, this is indicating highlighted G1 and G2. It indicates that G1 and G2 is not available in the circuit. So how to make a pulse generator? So to take the pulse generator block. In this pulse generator block, make it time based. Give the amplitude of 10. uh, Time period, how much time period is to be given? Time period of this must be given as 1 by 50 seconds. So it is 0.02 seconds, because our frequency of the supply is 50. So time period is 1 upon frequency, that is 50. Give the pulse width of 5%, it's okay. Now time delay is decided by the firing angle alpha. So firing angle alpha should be given in seconds. So we are going to give in a degree. So now we'll set this alpha. Okay, so alpha divided by 180. This, sorry, I want to calculate, I want this alpha. Alpha must be converted first into, uh, this alpha is in degree. Now we want to convert it is into second. So how to convert into second? Because one complete cycle is of 360 degree. But alpha degree is how much seconds? So it must be alpha divided by 360 multiplied by 1 upon 50 hertz. Okay, so timing is multiplied. So alpha divided by 360 will convert it into per unit, and 1 into 50, when you multiply 1 by 50, it is in second now. So first gate pulse is generated here. So this pulse is what? My G1 pulse. Okay. Now I want G2 pulse, gate pulse. So I will take this another G2 pulse. But gate G2 pulse, which is for the thyristor T3, uh, okay, thyristor T3 G3 G2 pulse, it must be 180 degree added to the alpha. So alpha, because after a positive half cycle, this G2 should be, or thyristor T3 must be conducted. So alpha plus 180 divided by 360 into 1 upon 50. So this is my G2 pulse. Okay, let me tell you, as your thyristor is a G3, you can rename to this as a G3. So now I will change this is to G3. Still I have not connected the go to block. So connect the go to block. Okay, first connect this go to block here. Give this name as name G1. Make this variable as the global. Apply. As soon as you apply this, so see it is showing the connectivity with this block. Okay. Then take another block, copy the same one, paste here, give this name as G3 block. Okay, then it will automatically get connected with the third thyristor. See, it is highlighted here, G3. This G3 is connected to this G3. Now gate pulse is also given. So let's form a area so that it looks good. So take the area from here. You paste this area. So this is what my power circuit. Okay, so click to this arrow. Then you type the power circuit. Then again took another area, paste here. In this area, we are generating the pulse circuit. Okay, so pulse generation is here. Okay, now we want observe the output. Okay, so we want observe the output. So for observing the output, what we need here, input signal, output signal, input current, input voltage, output current, output voltage. So let us start with the from block. From, okay, in the first block, rename this block as VS. You click on updating the tag. Okay, so see, okay, it is connected to this VS block, that is source voltage is measured here. Copy this same 4 times. I'm copying this same as in 4 times. So here the block name must be, here I want to measure the V0. So V0 output voltage. Here I want to measure the output current, and last one I'm going to measure the source current. Okay, then take the block of scope. Okay, take the block of scope, double click to this scope block. It will open its setting. So let it is opening. Okay, so in this setting you set this total number of axes to 4. I want the 4 axis, and say 2 by 2 layout. Okay, so 2 by 2 layout, apply. Okay, so as soon as you select with the 4 1, so you can see 1 2 3 4, it is created here. Now you increase this size, connect this block here, this block here, this block here, and this block here. So it will measure, it will give the waveform in the scope. I want to observe this waveform up to 0.2 seconds only. Okay, so I need only 20 cycle, 10 cycles. So I will observe up to 0.2 seconds. So if I run this file, before running this file, we have to add the Power GUI block into this, because every power system or power electronics simulation need the power graphical user interface. So you paste the Power GUI block here. Anything. Okay. So I will create one another area. So in this area, you are observing the waveforms. Okay, if you want to change the color of background, you can change the area color as you want. So I have changed it to can. Right click and right click here and change the area color. You can change the area color. Okay, so now here all measurements are available. If I start running this, then first I have to set the simulation status. So go in the right corner where you will see the variable step auto. Click to that. Go into the settings. Here we need to change the solver. Okay, so this power system simulations and power electronics simulations always work good on OD23T. Okay, so ordinary differential equation solution with 23T method is trapezoidal method. Click on apply. Okay, so everything is set now. If I run, it will give me error. Why it will give you error? Let's check. So if I start running this, okay, so it is what started updating library document. So what is the error it is given? Phase delay. Okay, so phase delay which is available in the pulse generation, because here we have set in this pulse generation we have set the phase delay as alpha, but alpha is not defined. So come to the command window of the MATLAB and paste alpha is equal to 30 degree. I need a 30 degree because it is given in the simulation. So simulation statement. So alpha is taken as a 30 degree. Now see in the workspace alpha is equal to 30 degree. Now if you run this simulation, okay, so it is running. Wait, sometime in the first time it takes the time to complete. Okay, it is completed. Now double click to this scope. So you can observe into this scope as my input is a sinusoidal, output voltage is having 30-degree firing angle over here. If you want to check it, you can zoom this for two to three cycles. So let me zoom. Okay, you click on zoom and this arrow. So you can check here, you will observe that it is the firing angle delay of the 30 degrees. Similar, the current is observed and the source current is distorted. So current is not a pure sinusoidal, it is a distorted one. So, but here we are not able to recognize which waveform is of voltage, which waveform is current. So how we can set it? So double click on this VS line and type it as the source voltage. Then this is the output current, output voltage or load voltage. Then type on this third one as output current and last one as source current. Okay, now run this. Now you can observe the name source voltage, output current, source current. If you want to edit this file, you can go into print to figure. Okay, so file print to figure. So it will open in the another window as a figure window. Okay, as a figure window, it is open. See, it is now name is not a scope. It is a figure window. I can edit. Go to the tools. Sorry, go to the property editor block. Okay, it will open the property editor block. So on the bottom side. Now I can change this figure color as a white. Okay, so and a background color as also white. So everything I can change it to white, or you double click in this block, you directly you can set the axis must be white, a border color must be black, alphabet must be black, but figure color must be white. Okay, so you can change this according to your requirement. You can change this you can change this line plot also. I can change this line plot with the thickness of 2. Instead of yellow color, I can change it to red. Okay, so anything we want to change, you can change it. Or another way to change this is, okay, I will show you the another way how to change it. Come into the scope. In the scope window, you click on file, then okay, sorry, uh, let me zoom out it first. Okay, everything is zoom out. So let us press this. Okay, now you can go into the style. In this style, I can change the color of each plot. Figure color as a white, axis color as a black. You can click on apply. So see, background color is changed, but axis color is still black. So axis color, you want to change it to white. So you click on white, apply, okay. So if I want to change this plot, line plot, I can change with the thickness 2 and black color. You can make it apply. Okay, for axis 1, for axis 2 also I can change it to I can change it to 2. Color is black. Most of the time students are not knowing how to change this background color and everything. Okay, so you can change this background color and everything uh, with this view style layout. Okay, so click on this or view again style. I can change this third plot also with the thickness of 2, then its color as the black. Then the fourth one is thickness of 2 with the color as a black. Okay. Now you can see your names of the source voltage, output current is not clearly visible. Then you can click to print to figure. Okay, in this figure window, I can edit anything as I want. So go to the figure properties. Okay, you can click to this title source voltage. You can make this color as font color as black, font color as a black. Okay, this font color also I want as a black. Okay, this source current also I need into the black color. Similarly, uh, each axis font, I need it into the color of black. Okay, so and font size I can increase to my requirement 14. Okay, or anything you want, you can change this font size. Likewise, you can change it, and you can export this figure to export this setup to, or you can click directly export this setup. Here I can change everything at one point. So size, okay, its size is okay. Rendering, come to the font. Okay, I want minimum font size of 14 font size. Okay, then I will click apply to figure. See, and here I need line color, line width, fix line width of 2 point. Okay, apply to figure. So then now everything line width will be changed to the 2 points. Sorry, 12 point is coming. So I need 2 point line width. So apply to figure 2 point line width. Hmm. Then I can change font, customize the font also. I can change the background color from here. Anything if I want to change, I can change from here. Then you can click on export and you can export this figure into JPG format directly. Okay, so you can export this figure into figure format or JPG format directly. So this is the easiest way to edit the everything. Okay, so by this way clicking to the every figure you can edit it. Okay, so hope you got it. So next time in next video we will see how to measure the power, how to measure the RMS value, average value, then input power, output power, everything. Okay, so that we will see in the next video. Thank you for now. Hope you understand this simulation of semi converter. If you like it, please subscribe my channel and share with your friends. Thank you.